if something is accelerating, that requires a force. The acceleration of gravity is actually upward. It's not downward. First, consider a situation where there is no gravity. Things move about freely, with no forces being applied to them. In physics, this kind of motion is called inertial. Things are moving or not moving by way of their own inertia only. If we're observing something while we ourselves are moving about inertially, we say that we are in an inertial frame of reference. Objects moving inertially, as measured in an inertial reference frame, travel at a constant velocity. Nothing is accelerating. This is captured in Newton's first law of motion. There's no way to define what's moving and what isn't. All motion is relative, and if we want to say that an object is at rest, we have to specify that it's at rest relative to some reference frame. Measured against a different reference frame, that same object might be moving. There's no such thing as absolute motion or absolute rest. But now suppose that we fire up an engine and begin to accelerate in one direction. From inside our spaceship, now things have changed. We can tell that we're no longer in an inertial reference frame. If we release an object, it begins to move as if a force is acting on it. It accelerates. But no such force actually exists. The object is just floating freely, and the spaceship is speeding up around it. The ship's walls are now constituting an accelerated or non-inertial reference frame. And in that reference frame, inertial objects appear to accelerate in the opposite direction. Inside an elevator car, you couldn't tell whether it's sitting on the surface of the Earth or in deep space and being accelerated in the direction of the ceiling by 9.8 meters per second squared. In either case, if you let go of an object, it will accelerate toward the floor at that same rate. But from the perspective of the object, that is, in its inertial reference frame, the elevator car appears to be accelerating ceilingward. When you step on a scale, you aren't directly measuring your mass. You're measuring the force. That force is proportional to your mass. A scale wouldn't measure your weight in deep space, unless your ship happens to be accelerating.